Good day, everyone. Today we are going to continue our discussion on the integration procedures. So last time we talked about integration by parts. So we've learned this formula, the integral of u dv equal to u times v minus the integral of v du. Okay? So last time we solved 3 examples. Today we're going to see the solution of the 4th and the 5th example. So the ones that you had solved. Okay, so example number 4. So we're given the integral of x cosine 2x times dx. So there are 2 approaches, class, in solving this problem. So today I'm going to show you the 2 ways of solving this problem. Of course, part of it is integration by parts. So before I apply this formula, so I will transform this into another form of an integral function by letting or using another variable. Like if I let a here, this part here, I will represent this into something like a. So if I let 2x equal to a, okay, so that we can replace this, we have only only one factor expressed this into one factor. So I will let this 2x as a. Then from here, I can also change the x in terms of a. So we can solve a here by dividing, we can solve x by dividing 2 both sides. So a divided by 2. On the right side, 2x divided by 2, so equal to x. And if we are going to take the derivative of a with respect to x, or take the differential on both sides, so we have derivative of a with respect to x is equal to 2, right, from our differential calculus. So solving for dA, so our dA is equal to 2 times dx by multiplying both sides by dx, or cross multiply dx. And from here, we can also solve for dx in terms of dA, because we replace this into, or by a, then we express this in terms of a. So we have to express dx also in terms of a, which is dA. Since this is differential of x, so we have to express this in terms of differential of a. So we can solve dx here by dividing both sides by 2. So we have dA divided this by 2, so equal to dx. And after that, substitute, change this in terms of a. So we have our new integral function as integral of, instead of x, our x is equal to a over 2. Then instead of cosine 2x, so we have cosine a. Then instead of dx, so we have dx equal to dA over 2. Alright, and we can rewrite this as integral of, so I'll do it like this, class. So this will be a over 2 is the same as 1/2 a, and cosine a, and dA over 2 is the same as 1/2 dA. Okay? Then we have here the constants 1/2 and 1/2, since they are just factors of this integrand, then we can multiply them. And then since that is their constant, so the product of these 2 constants, we can put this on the left side of the integral sign. So 1/2 times 1/2, that is equal to 1/4. So integral of a cosine a times dA. Okay, so from here, we can use the integration by parts formula by finding what is our u and what is our dv. So we can select from these factors here, from this integrand. We can select what is our u. Then once you have selected what is your u, then the remaining part of this factors here of the integrand will be our dv, so that we can use this integral of u dv. So this one here, we have integral of u dv. Okay, so if I let, say for example, if I let u be equal to a, then what is remaining? If I let this a equal to u, then the remaining here will be our dv. So dv would be cosine a dA. Okay, then finding the differential of u and the differential of a, so we have therefore du equal to dA. So it's just the same as when you take the derivative of u with respect to a, so you have du. Okay, so that we can be consistent, class, we will do the same as in our previous examples. So differentiating differentiating u with respect to a, so you have derivative of u with respect to, derivative of u so derivative of u with respect to a equal to, so derivative of u with respect to a, so you have to take the derivative on both sides. So derivative of a with respect to a is equal to 1, right? Then multiplying both sides by dA or cross multiply dA, so we have our du equal to dA. Okay, then from here, if you're going to integrate both sides, so integrating both sides, so the left side we have no problem because it's a perfect dv, so integral of dv is equal to v. On the other side, on the right side, you have to check if you have a perfect du here or dA or a perfect differential. So cosine u, or u is equal to a, then look at the differential here. Is it the perfect differential of u here? So if our u is equal to a, so derivative of, or the differential of a is equal to dA. So exactly the dA of the differential of this a here. Alright, so we can use the formula. Now if that is the exact, if you have an exact du here, then you can use the formula of the integral of, so we have the formula, class, that the integral of cosine u du equal to sine u plus c. Okay, assuming that this is a perfect du. Now after checking, then you can use this formula. So therefore we have integral of cosine a dA is simply sine a. Alright, so in summarizing, so let us summarize this. So we have our u, which is equal to a, then our du, which is equal to dA, then our dv, which is equal to this one. So this is equal to cosine a dA, then our v equal to sine a. And as I have taught you last time, to easily find out the information that we are going to use to substitute in this formula, so we have to draw a vertical line, draw a horizontal line, then from our formula, okay, I will continue. I'll continue it here. Now from here, class, now from here, so I'll continue it here. So we have equals, we have 1/4 times the integral of a. I am just copying it, class. A cosine a dA. Okay, this is equal to 1/4 times, this is our u, right? This is our u dv, no? Integral of u dv. So using the formula, integral of u dv is u times v minus integral of v du. Okay? So the whole thing here is multiplied by 1/4. So you put this in a bracket, inside the bracket. So we have using this formula, integral of u dv, u dv. So you have uv, where our u is, this is our u. U is equal to a. So we have a times v. Our v is sine a. Then minus the integral of v, no, v du. No, v du. Our v is sine a, and our du is equal to dA. So dA. All right. So equal to 1/4 times a sine a minus. So let us check if we have here a final complete, no, or perfect differential, so that we can use the formula. So there's a formula, class, that the integral of sine u du is equal to minus cosine u, then plus c. So let's try to see if we can use that formula. Okay, so we have here our u is equal to a, so du is equal to dA. So this is a perfect perfect du. Perfect du. So we can use this formula. Integral of sine u du is equal to minus cosine u plus c. So this is minus cosine a, then plus c. So this is equal to 1/4 times a sine a, then distribute this 1/4. Okay, so multiply on its term. So we have 1/4 a sine a minus minus, so that will be plus. Then 1/4, so this is 1/4 cosine a, then plus c. Then substituting the value of a, where our a is equal to this one. Our a is equal to 2x. So substituting, so we have 1/4 times a, which is equal to 2x. Then sine a, our a is 2x. Then plus 1/4 cosine a is 2x, then plus c. So equal to 1/4 times 2x, so that is 1/2 x, then times sine 2x, then plus 1/4 cosine 2x plus c. Okay, so this is our final answer. I hope you were able to follow, class, the explanation and this discussion. Okay, if you have any question, you may message me in our GC. See you again in our next video. I will show you the other solution of this problem, class, of this item in our next video. Okay, see you. Bye.